In this video we will be doing something a bit different. We will explore Earth's earliest stage in the form of a documentary-style story. The Hadean Era, an era full of the harshest environment Earth has ever seen. If you enjoy these videos, please feel free to leave a like and/or subscribe. Close your eyes. Let your body settle heavier now, sinking just a little deeper into wherever you are. Because I want to take you somewhere. Somewhere that no eye has ever seen. Somewhere that no foot has ever touched. Somewhere that, in the whole of all the universe, only I remember. I want to take you to the very beginning of me. My name, the name you gave me, the name I have grown fond of is Earth. And I am very, very old. 4.5 billion years old, to be almost precise. Though I confess, I did not keep careful records in those early days. I was otherwise occupied. What you are about to hear is my story, told from the only perspective that matters, mine. I was there for all of it. Every collision, every flood, every silence, every fire. I felt every one of them. Some hurt. Some were extraordinary. Most were both at once. I will not rush. I have never been in a rush. Time, after all, is something I have in extraordinary abundance. So breathe with me. Slowly. Let me tell you what it felt like to be born. It did not feel like waking up. It felt like being pulled together slowly, violently, irresistibly from nothing. From dust. From gas. From the scattered remnants of something else that had ended long before I began. There was a star, you see. Before me, there was a different star. Massive, old, magnificent, and then, one day, gone. It exploded. It scattered itself across an enormous stretch of dark, cold space, and what it left behind was a cloud. A vast, slowly rotating cloud of hydrogen and helium and heavier elements, carbon, oxygen, silicon, iron, the bones of that dead star, drifting. For millions of years, that cloud drifted. And then, gravity. Quiet, patient, inexorable gravity began to whisper to every particle in that cloud. Come closer, it said. Come together. And because gravity always wins, they did. At the center of that great, collapsing cloud, a new star ignited your sun, my sun, blazing into life. And around it, the leftover material, the dust, the pebbles, the chunks of rock and ice began to orbit, began to collide, began, piece by piece, to find each other. That is how I began. Not with a single moment. Not with a bang, though there were many bangs, but with an accumulation, a gathering, a slow, grinding, tumbling process of accretion that went on for millions of years. Pebbles became boulders. Boulders became mountains. Mountains became the cause of worlds. And one of those worlds was me. I want you to imagine what I looked like then. No blue, no green. No white swirls of cloud or brown continents or silver rivers catching the light. None of that existed yet. What I looked like 4.5 billion years ago, in those first raw moments of my existence, was fire. I was a ball of molten rock, roughly the size I am today, glowing orange and red and white in the darkness of space. My surface was not solid. There was no surface, not really, only an ocean. An ocean not of water, but of liquid rock. Magma, you would call it. Stretching across every inch of me, kilometers deep, churning slowly like a vast, impossibly hot sea. The sky above me, if you could call it a sky, was thick with volcanic gases. Carbon dioxide, sulfur dioxide, water vapor, though no liquid water could survive yet. The air was a poison. It was a soup of chemistry, violent and hot, pressed down upon my molten face like a heavy blanket. There were no clouds as you know them. The light from the young sun filtered through a red-brown haze, and the whole world, The whole of me glowed from within. I was beautiful, in the way that only truly dangerous things are beautiful. This period, this first chapter of my life, scientists in your time call the Hadean Eon. They named it after Hades, your old word for the underworld. The land of fire and shadow and things not meant for the living. They were not wrong. The Hadean began when I formed, approximately 4,540,000,000 years ago, and it lasted for roughly 540 million years. 540 million years. Let that settle somewhere in your mind for a moment. Your entire human civilization, every city, every empire, every generation from the first toolmaker to the last spans perhaps 10,000 years. The Hadean lasted 54,000 times longer than that. And it was only the first chapter. I mention this not to make you feel small. I mention it because I want you to understand the kind of patience this story requires. The kind of patience I required, just to become what I eventually became. Patience is perhaps the first thing I ever learned. In those earliest years, I was not alone in my chaos. The young solar system was a crowded, violent place. The space around the sun was filled with planetesimals, rocks, and protoplanets of every size, all jostling for orbit, all colliding with anything in their path. And regularly, catastrophically, they collided with me. I was struck constantly, battered, pelted. Every impact added to my mass, added to my heat, stirred my molten interior like something vast and slow being stirred in a pot. Most of these impacts were large, but forgettable in the way that any individual raindrop is forgettable in a storm. But one was not forgettable. One was the single most important thing that ever happened to me. Approximately 4,500,000,000 years ago, very early, almost in my infancy, something hit me. Not a rock. Not a large rock. Not even a mountain-sized rock. A planet. A planet roughly the size of Mars, perhaps a third of my diameter, perhaps a tenth of my mass, that had been quietly forming in an orbit near mine. It had been growing, gathering material, developing its own gravity and its own heat. It had been, in its own small way, becoming something. Scientists in your time call it Thea, a name from Greek mythology, a goddess of sight, mother of the moon. That name feels right to me, because when Thea hit me, it changed what I could see. It changed what I could become. It changed everything. The collision was not like anything you can picture from the world you know. It was not quick. Planetary collisions, at their scales, are slow. They unfold over minutes, perhaps hours, as two massive bodies interpenetrate each other, their gravities tangling, their mantles merging, their cores searching for each other through oceans of liquid rock. When Thea struck me, she struck obliquely, a glancing blow, not a direct hit. Her iron core plunged through my outer layers, merged with my own iron core, and sank deep into my interior. Her mantle, her rocky outer layers, was flung outward in an enormous spray of vaporized and molten rock that surrounded me in a great ring of debris. And for a time, I had rings. Like Saturn. As you know, Saturn, a ring of rocky, molten material orbiting me in a bright, hot band. That ring did not last long. Gravity, again patient, inevitable gravity, pulled it together. It clumped. It coalesced. And within perhaps a few thousand years, it had assembled itself into a single body, orbiting me at close range. The moon, my companion, my child, in a sense, made from my own shattered material and the bones of the world that gave itself to me. I want to tell you what the moon meant to me in those earliest years. It was close. Much closer than it is now, perhaps a fifth of the distance it is today. If you had stood on my surface then, you would have been instantly vaporized. But imagine, the moon would have looked 15 times larger in the sky than it does now. It would have filled a great arc of the heavens, enormous and orange, its own surface still molten, still glowing from the violence of its formation. We pulled at each other, the moon and I. Its gravity gripped me, and because it was so close and so massive in relative terms, it pulled on my molten surface in enormous tidal waves. Not water, I had no water yet, but waves of magma, slow and vast, rising toward the moon and falling away as the moon moved in its orbit. It was the moon that set me spinning at the pace I would come to know. It was the moon that stabilized the tilt of my axis, giving me, eventually, my seasons. It was the moon that would later drive my oceans in their great rhythmic breathing. Even then, barely formed, we were already intimate, already necessary to each other. I was not entirely alone in the dark. Let the images soften now. Let the fire dim a little, not extinguished, not yet, never yet in those years, but let it soften at the edges of your mind. You are 4.5 billion years in the past. You are the heat at the center of the world. You are the slow, patient turning of a young planet finding its way through a violent solar system, pulling itself together piece by piece, surviving blow after blow, growing heavier and hotter and more itself with every passing million years. There is no life here yet. No sound but the deep, subsonic shudder of tectonic forces and the hiss of volcanic gases. No movement but the slow convection of magma churning beneath a surface that is not yet ready to be solid. But there is something. Even now, even here, in all this fire there is the beginning of a shape, a possibility, a world that is, slowly and painfully, becoming itself. That world is me. And I am just getting started. Rest here for a moment if you need to. Let the fire be somewhere far beneath you. Let it be warm and distant and old. When you're ready, we'll go a little deeper into the Hadean, into the rain of comets, the first whisper of water, and the long, slow cooling that would one day, hundreds of millions of years from now, allow me to grow something like a skin. But there is no hurry. There never was. Then let me take you a little deeper, a little further back, deeper into the fire, deeper into the dark, deeper into the years that have no name in any human language because no human was there to name them. I was alone then, utterly alone, in the way that only very large things can be alone, surrounded by everything, touched by nothing that truly knew me. But the solar system was still young, still restless, and it was not finished with me yet. In those earliest tens of millions of years, I was being built. That is the only word for it. Built. Not designed. There was no architect, no intention, no plan. Only physics. Only the blind and patient arithmetic of gravity and momentum and mass, doing what it always does, pulling things together, making them larger, making them hotter, making them more. Every day, if you could call them days, when I was spinning much faster than, completing a full rotation in perhaps 5 or 6 hours, the sky above my magma ocean delivered something new. A meteorite here, a large impactor there, a slow, grinding rain of rocky debris that had not yet found a home. I absorbed it all. This is what young planets do. They eat. They consume everything in their orbital path, sweeping up the loose material of the early solar system the way a rolling ball of dough picks up crumbs. Every impact added heat, kinetic energy converted instantly to thermal energy, shockwaves rippling through my liquid interior, keeping me molten, keeping me churning. I was not passive in this. My gravity was doing the work. I was pulling them in. I was hungry, though I did not know I was hungry. I simply was. But then perhaps 4 billion years ago, perhaps a little before, something changed in the outer solar system, far beyond me. In the cold dark where the giant planets lived, Jupiter and Saturn, Neptune and Uranus, something shifted. A slow gravitational dance between those great worlds gradually changed their orbits in tiny increments, until their rhythms fell into resonance with each other. And that resonance sent a shockwave through the whole solar system. It destabilized something called the asteroid belt. And what had been a relatively quiet field of rocky debris became, suddenly, a shooting gallery. Thousands upon thousands of asteroids, rocks the size of cities, rocks the size of mountains, rocks the size of small countries were knocked loose from their orbits and flung inward toward the sun, toward the inner solar system, toward me. This event, in your geological vocabulary, is called the late heavy bombardment, or sometimes the lunar cataclysm. It lasted perhaps 200 million years. And during those 200 million years, I was struck more times than I could count, which is to say, uncountably many thousands of times by objects large enough to leave permanent scars, and billions of times by smaller fragments that simply dissolved into me. I know this happened partly because of the moon. My moon, being smaller, being geologically quieter than me, preserved its wounds. When your scientists looked up at it through their telescopes, they saw craters everywhere, vast, overlapping basins, hundreds of kilometers across, the frozen records of an ancient violence. Those craters are the moon's memory of what we both endured. I erased most of my own scars, eventually, but the moon remembered me. I want to describe what a major impact felt like. Not the small ones, those were constant, routine, the background percussion of my early existence. I mean the large ones. The ones that hit me during the bombardment with enough energy to briefly remelt portions of my surface, to send shockwaves through my entire body, to ring me like a bell. Imagine if you can a rock 50 kilometers across, traveling at perhaps 20 kilometers per second. 100 times the speed of sound, aimed, by nothing more than orbital mechanics and bad luck, directly at me. It would not slow as it entered whatever atmosphere I had then. It would pass through it in seconds, barely noticing it. And then it would hit. The impact would release more energy than all the nuclear weapons ever built by human hands, detonated simultaneously. The rock would vaporize in an instant. The ground around the impact site is already molten, but this would supercharge it, would be flung outward in a curtain of liquid rock and vapor. A crater hundreds of kilometers wide would form in seconds. A shockwave would travel through my entire body, compressing my iron core, rattling my mantle, sending ripples across my magma ocean on the opposite side of the world. Then, over hours and days, the vaporized rock would rain back down across my entire surface. Every piece of ejector launched into orbit would return, one by one, each small piece adding its own tiny impact, until the entire sky seemed to be falling. For perhaps weeks after a major strike, the sun would be invisible through the clouds of ash and vapor and condensed rock fog. And then, slowly, the surface would begin to settle again. The magma ocean would resume its slow, quiet churning. The haze would thin, and I would carry on. This happened thousands of times. I want you to understand something about that. The endurance of it. Not suffering, I did not suffer, not in the way a living thing suffers, but the sheer, sustained persistence of it. Being struck, and struck, and struck again, and each time simply absorbing it, incorporating it, continuing. Perhaps that is the first thing I truly learned about myself. I do not break. But the bombardment gave me something, too. This is the part one find most extraordinary, when I think back on it. The very thing that was tearing at me, cratering me, keeping me hot and wounded and raw was also, in a quiet way, making a gift. The asteroids brought water. Not all of them. The ones that formed close to the sun close to me were dry, rocky, iron-rich things. Water cannot survive the heat of the inner solar system in those first volatile millions of years. It boils away, It dissociates. It is driven outward by the pressure of solar radiation. But the asteroids from further out, and especially the comets, those ancient wanderers from the cold fringes of the solar system, were full of ice. Water ice, locked into their rocky matrices, preserved for billions of years in the deep cold beyond the orbit of Jupiter. When they hit me, they died. The impact vaporized them in an instant. But the material, the water molecules, the carbon compounds, the nitrogen, the organic chemistry frozen into those ancient bodies of ice and dust, that material survived. It mixed into my atmosphere. It mixed into my surface. Drop by drop, in the way that anything accumulates over millions of years, the water arrived. Most of it was immediately lost again. In those early years my surface was too hot, my atmosphere too thin and chaotic to hold it. Steam would rise and then dissipate, or be stripped away by the energetic young sun, which in its own early life was throwing out tremendous bursts of charged particles that battered the outer layers of whatever atmosphere I was trying to maintain. But some stayed. A little. Always a little more. And in the depths of the magma ocean, water molecules were being incorporated into the rock itself, locked into the crystal structure of minerals, stored in the interior, waiting. Not consciously waiting. Simply waiting, in the way that all things wait that have no choice. My water was accumulating inside me, even while my surface remained bone dry and burning. There is a mineral I want to tell you about. Its name, in your language, is zircon. A small thing, a tiny crystal, no larger than a grain of sand, colorless or pale pink, unremarkable to the eye. You would walk past it without a second glance. But zircon is extraordinary for one reason. It survives everything. Zircon crystals form in magma, and when they crystallize, they incorporate uranium into their structure. That uranium decays, slowly and predictably, into lead, and because the rate of that decay is constant and well understood, scientists can look at a zircon crystal and read its age with remarkable precision. And some of the oldest zircon crystals ever found on my surface, found in a place called the Jack Hills in Western Australia, have been dated to 4,400,000,000 years ago. 4.4 billion years. These tiny crystals formed within 150 million years of my birth. And they survived. Survived the bombardment. Survived the geological violence of billions of years. Survived the slow recycling of my crust and the movement of my tectonic plates, and eventually came to rest in a riverbed in Australia, where a geologist picked one up in the late 20th century and changed everything we thought we knew about how quickly I cooled. Because zircon does not form in magma oceans. Zircon forms when rock is cool enough to crystallize properly. It forms in something approaching solid crust. It forms, sometimes, in the presence of water. Those ancient zircons tell me something I find quietly remarkable about my own early life. That even during the bombardment, even in all that fire, parts of me were already trying to cool. Parts of me were already reaching, however briefly and unsuccessfully, towards something more solid, more permanent, more like what I would eventually become. The bombardment ended. Not suddenly. Nothing in my life ends suddenly, not on geological timescales. It tapered. The flood of impactors from the outer solar system slowly diminished as the supply of destabilized asteroids was exhausted. The shooting gallery quieted. The sky, gradually, cleared. By approximately 3,800,000,000 years ago, the worst of it was over. My surface was battered, craterized, scarred in ways I have since mostly healed, mostly erased, mostly folded back into myself through the slow recycling of my crust. But I was still here, still turning, still warm and alive with internal heat, still carrying the seeds of what I would become. And something important had changed. My surface was beginning slowly, tentatively, incompletely to cool. just at the edges, just in patches, just in the way that a very hot object cools first at its surface before the interior follows, a thin skin of solidifying rock forming and reforming, breaking apart under the stresses of the magma beneath, melting again, but then reforming just a little thicker. It was the very beginning of a crust. My skin, forming for the first time. I was starting, after all of this, after the formation, and the theater impact and the bombardment and the fire, to have something like a surface. A place, eventually, where something else could stand. Let that image settle. A thin skin of dark rock, fractured and impermanent, floating on a sea of fire. Above it, a sky choked with volcanic gases, lit orange by a sun that was younger and slightly dimmer than the one you know, and crowded still with the last fading echoes of the bombardment. No oceans yet. No continents. No breath of oxygen. No living thing anywhere in the universe, not here, not yet, perhaps not anywhere. But a surface. The first hint of a surface. Something is beginning. In the next chapter, we will follow what happens when my skin finally starts to hold, when the heat begins to lose its argument with time, and something extraordinary falls from the sky. Not rock this time. Rain. There is a sound I want you to imagine. Not a loud sound. Not an explosion. Not a collision. Not the deep subsonic shudder of magma moving beneath rock. Those sounds you have heard from me already, and there will be more of them in time. This is quieter than all of that. This is the sound of a single drop of water falling through a sky full of steam and volcanic gas, and the last thin echoes of a bombardment that has finally begun to ease. Falling through air so hot that the drop half evaporates before it lands, becoming something between rain and mist, more vapor than water by the time it reaches the ground. But it falls. And somewhere on my surface, somewhere on the thin, dark, fractured skin of rock that has only just begun to hold its shape, that drop lands. And the rock hisses. And that hiss, that tiny, fleeting, almost nothing of a sound, is one of the most important things that has ever happened to me. Let me tell you how I learned to cool. Cooling, for a planet, is not like cooling for a cup of tea left on a table. It is not simple, not passive, not quick. It is a negotiation, a long, complicated, often interrupted negotiation between the heat locked inside me and the cold of space waiting outside. The heat inside me came from two places. The first was my formation. When I was being built, when all those planetesimals were raining down and merging into me, every collision released kinetic energy as heat. By the time I had accumulated most of my mass, I was almost entirely molten. The energy of my own construction had cooked me from the inside out. The second source of heat was radioactivity. Inside my rocks, inside the minerals that made up my mantle and my crust, there were unstable elements. Uranium, thorium, potassium-40, radioactive isotopes that decay over millions and billions of years, releasing energy as they go. In those early years, there were far more of these unstable elements than there are now. The rate of radioactive decay in my interior was much higher then. It was like having millions of tiny furnaces distributed throughout my body, each one burning slowly and steadily, contributing their warmth to the whole. This heat had to go somewhere, and the only place it could go was out. Heat moves through rock slowly, much more slowly than through water or air. And so the heat in my deep interior conducted outward, degree by degree, toward my surface. And at my surface, it radiated into space. And space received it without complaint, as space always does, being infinite and cold and utterly indifferent. But the rate at which I could lose heat was limited by the thickness and composition of whatever lay at my surface. And in those early years, what lay at my surface was chaos. The magma ocean was its own complicated system. I want you to picture it, just for a moment, before we move on from it, because it will not be here much longer, and it deserves a proper farewell. The magma ocean was not uniform. It was not a still, flat sea of uniform liquid rock. It was a churning, convecting system, constantly in motion, driven by the same heat that kept it liquid. Hot material rose from the deep interior, spread across the surface, cooled slightly, became fractionally denser, and sank again only to be reheated and rise once more. A slow, enormous circulation. The planet breathing, in a sense, though I did not yet know what breathing was. As material cooled at the surface, it began to crystallize. Different minerals crystallize at different temperatures, and so as the magma ocean slowly cooled from the top down, it began to sort itself. Denser minerals crystallized first and sank. Lighter minerals rose. The chemical composition of my interior was being separated and organized, layer by layer, by nothing more than the physics of cooling rock. This process is called fractional crystallization, and it is one of the reasons I am led the way I am. Dense iron core at the center, rocky mantle above it, and eventually a lighter crust at the surface. I was, in a sense, sorting myself out, finding my own internal order from the chaos of my formation. It took time. It always takes time. But by approximately 4 billion years ago, as the bombardment was winding down, as the supply of incoming impactors was finally dwindling, the magma ocean was beginning to lose the argument with cold. The surface was solidifying. Not everywhere, not permanently, not without interruption, but solidifying. Dark, heavy rock basalt, mostly rich in iron and magnesium, was forming at the surface and holding its shape long enough to matter. The crust was thin, perhaps only a few kilometers thick in places, riddled with cracks through which magma still welled up and spilled, broken and rebroken by the stress of the convecting mantle beneath. But it was there. I had skin, and skin changes everything, because skin is a boundary. And boundaries create the possibility of accumulation. On a surface of liquid magma, water cannot accumulate. Any water molecule that lands is instantly vaporized, launched back into the atmosphere in a puff of steam, never staying, never building. There is no purchase, no place to gather. But on solid rock, even hot solid rock, water behaves differently. It still hisses. It still partially evaporates, but some of it stays. Some of it seeps into cracks in the rock, cools slightly, pools in the low places. Some of it begins, for the first time, to collect. And my atmosphere, all this time, had been filling with water vapor. My interior, all those billions of years of geological activity, had been outgassing. Volcanoes are not merely destructive. They are also expressive. They release from the deep interior the gases that were incorporated into the rock during my formation. Carbon dioxide, sulfur compounds, nitrogen, and water vapor. Vast quantities of water vapor erupted from my interior over hundreds of millions of years and released into my atmosphere. The atmosphere was thick with it, heavy with it, a warm, dense, wet blanket wrapped around me, full of moisture that had nowhere to go because the surface had been too hot to receive it. But now the surface was cooling, and as the surface cooled, the atmosphere above it cooled too. And as the water vapor in the atmosphere encountered air that could no longer hold it in gaseous form, it did what water vapor always does when it cools past a certain point, it condensed. It became droplets. And the droplets fell. The first rain on Earth lasted a long time. Not a storm, or rather, not a single storm with a beginning and an end, but a prolonged, planet-wide episode of rainfall that may have lasted millions of years. Imagine that. Millions of years of rain. The sky was dark with cloud, not the soft white clouds you know, but thick, heavy, sulfurous clouds full of acid and steam, pressed down by an atmosphere denser than the one I wear today. The sun, when it could be glimpsed at all, was a dim and reddish smear behind the overcast. And it rained. The rain was not pure. It was acidic carbonic acid, sulfuric acid, other compounds dissolved from the volcanic gases in the atmosphere. It fell on hot black rock and it hissed and it reacted, dissolving minerals, breaking down the surface, carrying ions of sodium and calcium and magnesium away in solution. At first, most of it evaporated again. The rock was still too hot. The rain fell and became steam and rose and fell again, cycling, in an enormous and relentless hydrological engine, gradually carrying heat away from my surface with every cycle, helping me cool faster than I could have cooled by conduction alone. The rain was doing work. The rain was helping me. And gradually, the surface temperature dropped below a critical threshold. Below 100 degrees Celsius, below the boiling point of water at the pressures I was maintaining. And the rain that fell began, for the first time, to stay. It pooled in the low places, the basins and depressions of my cratered, fractured surface. It deepened, millimeter by millimeter, over thousands of years. It began to connect, one pool to another, spreading across my surface in shallow, hot, acidic sheets. The first ocean, not blue, not calm, not like anything you would recognize as ocean. Hot, acidic, shallow, full of dissolved minerals, steaming at its surface, churned by enormous tides from the moon still close above. The sky above it was not blue but orange and brown, lit by a dim sun and crisscrossed by the lightning that played constantly through the charged, turbulent atmosphere. But it was water, liquid water, on my surface, for the first time. I want you to feel the significance of that. Everything that follows, every living thing, every ocean creature, every fish and forest and whale and flowering plant and small mammal running through tall grass, all of it depends on that moment. All of it is downstream of that first shallow, hot, acidic pool of water, sitting quietly in a crater in the dark basalt of a cooling world. I did not know it then, of course. I had no way of knowing. But something had arrived that I would never again be without. The water changed me from the outside in. The moment liquid water existed on my surface, a whole new set of processes began. The water reacted with my rocks, a process called weathering, the slow chemical conversation between water and mineral. Silicate rocks absorbed carbon dioxide from the atmosphere, locking it into carbonate minerals. This drew down the carbon dioxide in my atmosphere slowly over millions of years, reducing the greenhouse effect and helping my surface cool further still. The water carried dissolved material into the growing seas. The seas became a repository of chemistry, a solution rich in minerals and salts and compounds, all of it bathed in the energy of sunlight above and the heat of hydrothermal vents below, where my interior heat was still finding its way to the surface through cracks in the new crust. This chemical richness, this warm, mineral-laden, energy-bathed water, it was not alive, but it was, without knowing it, preparing, building the conditions, assembling the ingredients, laying out the table, though the guests had not yet been imagined, let alone invited. I was still billions of years away from understanding what was happening inside me. But the water had arrived, and with water, everything becomes possible. Let the rain fall softly in your mind now. Let it fall on dark rock, somewhere far below you, somewhere 4 billion years away. Let it hiss against the basalt and pool in the low places and slowly spread. You are watching the first ocean being born. It is small. It is hot. It is nothing like the oceans you know, but it is real. It is he, and it is mine. Rest in that for a while. In the next chapter, we go deeper down beneath that new ocean floor, into the dark and the pressure and the heat, where my interior is still churning, still sorting itself, still doing the long, slow work of becoming the planet I will eventually be. Close your eyes a little more. Let the rain from the last chapter fade, still falling somewhere above you, that thin acidic drizzle on dark hot rock. But we are going down now, down through that new dark crust, down through the kilometers of cooling basalt, down through the boundary where solid becomes something stranger, something that is neither quite solid nor quite liquid, but moves like both depending on how long you wait and how hard you push. Down into my mantle. Down, eventually, to my core. This is where I truly live, in a sense. This is where my heat comes from. This is where the engine is. This is where, in the Hadean, the most important work of all was quietly being done, unseen, unfelt by anything on the surface, unremarked by any witness, because there were no witnesses. Only me. Let me tell you about iron. Iron is the sixth most abundant element in the universe. It is produced in the hearts of massive stars, forged in the nuclear furnaces of stellar cores during the last desperate stages of a star's life, when it has burned through all its lighter fuel and turns, finally, to fusing silicon into iron. Iron is the end of the line for stellar nucleosynthesis, the heaviest element a star can make before the process stops being energy-releasing and starts being energy-consuming. And when a star reaches iron, it collapses. It explodes. It scatters its iron across the cosmos. The iron in my core came from dead stars. Ancient stars, far older than the sun, that lived and died long before our solar system existed. The iron that sits at my center is older than I am, older than the sun. It has been iron since before this corner of the galaxy looked anything like it does today. I find that remarkable, that the oldest part of me is made of something that predates me entirely. When I was forming, when all those planetesimals were colliding and merging into me, when my interior was entirely molten, the iron had a choice to make. Or rather, physics made the choice for it. Iron is dense, much denser than the silicate rock that made up most of my body. And in a molten planet, dense things sink. It is the same principle that makes a stone fall through water gravity, pulling the heavier material down, the lighter material rising to take its place. And so the iron sank. Over perhaps 30 million years a blink. In my terms, the iron in my molten interior migrated downward, drawn by gravity toward my center, falling through the magma in droplets and streams and great slow rivers of liquid metal. It gathered at my core, compressing under the weight of everything above it, growing denser and hotter as it accumulated. This process is called iron catastrophe or core formation. And it was catastrophic in the most literal sense, a dramatic, rapid reorganization of my entire interior that released enormous amounts of gravitational energy as heat. The sinking iron gave up its potential energy, and that energy became warmth. My interior grew hotter as my iron sank, not cooler, a counterintuitive thing, but true. By the time the iron had settled, by the time core formation was largely complete, I had a dense, hot, liquid iron core at my center, surrounded by a rocky mantle of silicate minerals, and at the surface, the beginnings of that thin basaltic crust. 3 layers, each one distinct, each one essential. I had found my shape. The core is not uniform, and it was not always what it is today. In the Hadean, my entire core was liquid. Liquid iron, not the iron you know, not the iron of a bridge or cooking pot. Iron under pressures and temperatures that have no equivalent at my surface. Iron compressed to densities 3 times what it reaches at surface conditions. Iron at temperatures of perhaps 4,000 or 5,000 degrees Celsius at the boundary between core and mantle, rising to perhaps 6,000 degrees at the very center. This liquid iron was in motion. The core was convecting just as the mantle above it convected, just as the magma ocean had convected before it. Hot material rising from the very center, spreading outward as it approached the core mantle boundary, cooling fractionally, sinking again. A slow, churning circulation of liquid metal, moving under the influence of the heat gradient between my hot center and the slightly less hot boundary above. And this moving, conducting liquid iron was doing something that would turn out to be one of the most important things I have ever done. It was generating a magnetic field. A magnetic field is, in some ways, the most invisible and the most vital thing about me. You cannot see it. You cannot feel it, except with instruments, or with the compass needle that has guided your sailors and explorers for centuries. It does not make noise. It has no color. It is not warm or cold. But without it, I would be a very different world. Perhaps not a world capable of life at all. Here is what it does. The sun, my sun, our sun is not merely a source of light and warmth. It is also a source of something more energetic and more dangerous, a constant stream of charged particles, protons and electrons moving at hundreds of kilometers per second, blasted outward in all directions. This is called the solar wind. And in the early solar system, with a young and active sun still settling into its long stable middle age, the solar wind was stronger than it is today. Those charged particles, if they reached my surface unimpeded, would do several things. They would strip away my atmosphere, particularly the lighter molecules, the water vapor and nitrogen, gradually eroding everything I needed to become habitable. They would bombard my surface with radiation energetic enough to break apart the chemical bonds that life would eventually depend on. They would, over time, make me into something much more like Mars, which lost its magnetic field early in its history and has spent the billions of years since being slowly stripped of its atmosphere by exactly this process. But the moving liquid iron in my core, the convecting, churning ocean of conducting fluid at my center, was producing a dynamo, a self-sustaining electromagnetic generator, exactly analogous in principle to the generators that would one day power your cities, but planetary in scale and billions of years old. The dynamo generated a magnetic field that extended far out into space around me, a great invisible bubble, deflecting the solar wind, bending it around me, sending it streaming past rather than into me. My shield, my magnetosphere, whether it was fully active in the earliest Hadean, is something your scientists still debate. The zircon crystals, those ancient survivors from 4.4 billion years ago, carry hints that suggest a magnetic field was present even then, though perhaps weaker and more variable than the one I maintain today. But by the time the Hadean was well underway, by the time my core was well formed and vigorously convecting, the shield was up, and the atmosphere I was building, that thin, volcanic, water-laden blanket, had a chance of surviving. Let me bring you back up now, slowly, through the layers, through the core, where liquid iron churns in darkness at pressures beyond imagination, through the core mantle boundary, where the chemistry changes abruptly, iron giving way to silicate rock, dense and dark and strange under the conditions that exist there, exotic minerals that only form at those depths and that you will never hold in your hand. Through the mantle itself, thousands of kilometers of rock that is technically solid but behaves, over millions of years, like a very slow and very thick fluid. It flows, not quickly, a centimeter a year, perhaps, in some places, less in others, but it flows, driven by the heat rising from the core below and the cooling happening at the surface above. The mantle is the great engine of my surface geology. Everything that happens above the movement of tectonic plates, the building of mountains, the opening of ocean basins, The volcanic eruptions that have shaped every continent and seafloor, all of it is driven by the convection happening here, in the slow dark of my interior, where nothing can see and nothing can record. Except me. I feel all of it. The slow pressures, the gradual movements, the steady transfer of heat from inside to outside that has been going on since my formation and will continue for billions of years yet. I am warm inside. I will be warm inside for a long time still. There is something I want to say about all of this, about the core, and the mantle and the magnetic field and the slow convection that drives everything. It is this. None of it was planned. There was no intention behind the iron sinking to my center. No design behind the convection that generated the dynamo. No foresight in the magnetic field that protected my atmosphere from the solar wind. These things happened because of physics, because of the properties of iron and the behavior of conducting fluids in rotation and the mathematics of electromagnetism. And yet the outcome, taken together, was a planet almost perfectly equipped to eventually support life. The iron core gave me the magnetic shield. The magnetic shield protected the atmosphere. The atmosphere held the water. The water covered the rock. And somewhere in the interaction between the water and the rock and the energy flowing through the system, the heat from the interior, the light from the sun, the chemistry of the volcanic gases, something would eventually stay. I did not know any of this. I was not building toward anything. I was simply being what physics required me to be. But physics, it turns out, had arranged things rather well. The crust that was forming in these years was not yet the crust you would recognize. There were no granite mountains. No pale, ancient continental rocks rising above the sea. No sand, because sand requires the long patient work of weathering and erosion and the sorting action of rivers and waves, and most of those things did not yet exist in the forms you know. What there was basalt. Dark, dense, fine-grained basalt, the same rock that forms the floors of your modern oceans, the same rock that erupts from the shield volcanoes of Hawaii, the same rock that makes up the visible surface of the moon. Basalt is the most common volcanic rock in the solar system. It is what you get when the mantle melts and the melt reaches the surface. It is the default language of planetary surfaces, and in the Hadean, it was all I had to work with. The basaltic crust was forming continuously, welling up from the countless fissures and volcanic vents that covered my surface, spreading outward, cooling, darkening from orange to black as it solidified. And just as continuously, it was being recycled, dragged back down into the mantle by the stresses of convection below, melted again, re-erupted. It was a cycle, a restless, perpetual cycle of formation and destruction that kept the crust thin and kept the mantle churning and kept the whole system moving. But within that cycle, something new was beginning to happen. When basaltic crust is subducted, when it is dragged back down into the hot mantle, it does not simply dissolve back into what it came from. The process is more interesting than that. As the basalt descends, it is compressed and heated. Water locked into its minerals is driven out, squeezed free by the increasing pressure. And that water rises into the mantle rock above the subducting slab. And water, even in tiny quantities, does something remarkable to rock under pressure. It lowers its melting point. Rock that would otherwise remain solid at those temperatures begins to melt, not entirely, not uniformly, but partially. A water-fluxed melt, different in composition from ordinary basalt. Richer in silica, less dense, more buoyant. This melt rises. And when it reaches the surface and erupts, or when it cools and crystallizes before it gets there, it produces a different kind of rock. Lighter, more silica-rich. The beginnings, in crude and early form, of what geologists call felsic rock, and eventually, of granite. Granite is extraordinary stuff. It is less dense than basalt. Significantly less dense. And this matters enormously, because the crust floats on the mantle the way a boat floats on water, and a less dense crust floats higher. Granite rises. Granite, when it forms in sufficient quantity, rises above the ocean surface. Granite becomes land. In the late Hadean, the first hints of something like continental crust were beginning to appear. Not yet the great stable cratons that would eventually form the hearts of your modern continents. Not yet Gondwana or Laurentia or any of the named landmasses whose history geologists have painstakingly reconstructed. Those were hundreds of millions of years away, and they belong to the next chapter of my story, to the Archean and beyond. But the protocontinental material was there. Small, isolated patches of lighter, silica-rich rock, rising fractionally above the surrounding basalt, surrounded and occasionally submerged by the growing Hadean Ocean. They were not impressive by any measure you might apply today. Low, dark, wave-battered humps of rock, steaming in the acidic rain, surrounded by a gray-green ocean that smelled of sulfur and was warm as a bath. No soil covered them. Soil requires biology, and biology was not yet here. Just bare rock, wet and dark, with the rain hitting it and the waves pulling at its edges. But they were land. The first land. The first place on my surface was, even intermittently, above the water. I am fond of them, those first small scraps of continent. They were unprepossessing. They were temporary. Most of them were eventually subducted and recycled, their material incorporated into later geological formations, their existence preserved only in the geochemical signatures of the rocks that came after them. But they were mine, the first solid ground I ever had. While my surface was doing all of this cooling, crusting, thickening, building its first shy fragments of land, my atmosphere was changing too. In the Hadean, my atmosphere was nothing like the one you breathe today. There was no oxygen. Let me be clear about that. The air of the Hadean would kill you in minutes, not primarily through lack of oxygen, though that would kill you too, but through the sheer chemical hostility of what was there. Carbon dioxide in concentrations far above anything in your modern world. Sulfur dioxide from the relentless volcanism. Hydrogen sulfide. Methane, perhaps, in some quantities. Water vapor, vast quantities of water vapor, especially in the early Hadean, before the oceans had formed and absorbed much of it. Nitrogen was there. Nitrogen is a relatively inert gas, and the nitrogen in my early atmosphere was outgassed from my interior by volcanism, as it still is today in smaller quantities. Much of the nitrogen stayed. It built up slowly over time, becoming an increasingly significant part of my atmospheric composition. But the dominant gas in my Hadean atmosphere was carbon dioxide. This had consequences. Carbon dioxide is a greenhouse gas. It traps heat, absorbs the infrared radiation that my surface emits as it tries to cool, re-radiates some of it back down. The more carbon dioxide in an atmosphere, the warmer the surface beneath it, all else being equal. And in the Hadean, there was a great deal of carbon dioxide. This matters because of something called the faint young sun paradox, a puzzle that fascinated your scientists for decades, and which I lived through without knowing it was a puzzle at all. The young sun was fainter than it is today. This is simply a consequence of stellar physics. Stars like the sun gradually brighten over their lifetimes as hydrogen fusion slowly alters the composition of their cores. 4 billion years ago, the sun was putting out perhaps 70% of the energy it puts out today. By modern standards, it was dim. And dim means cold. The mathematics are straightforward, and they produce a troubling result. With 70% solar luminosity and an atmosphere similar in composition to today's, my surface should have been frozen. Entirely frozen. A snowball orbiting a pale young star. But the evidence in the zircon crystals never lies, says I was not frozen. The zircons, with their signatures of water and mild temperatures, say that liquid water existed on my surface from remarkably early in my history, perhaps as early as 4.4 billion years ago. So either the calculations are wrong, or the atmosphere was not like today's. The answer is the second one. Carbon dioxide, the methane, the thick, warm, chemically active blanket of greenhouse gases that filled my early atmosphere compensated. They trapped enough heat to keep my surface above freezing despite the dimness of the young sun. A natural greenhouse, enormous in scale, keeping me just warm enough to be wet. It was a balance, a precarious, slowly shifting balance between the heat I received and the heat I retained. And it was maintained, almost miraculously, for long enough to matter, long enough for the oceans to form, long enough for the chemistry to begin, long enough for everything that came next. I did not manage this balance consciously. I could not. But the physics managed it for me, and I am in whatever way a planet can be grateful for that. The Hadean was drawing toward its close. Not quickly. Never quickly. The boundary between the Hadean and the Archean, the next great chapter of my life, is defined by geologists as roughly 4 billion years ago, though the transition was gradual, with no single moment marking the change. The Hadean did not end. It became something else, slowly, in the way that all my transitions happen. But by 3,800,000,000 years ago, the world was a recognizably different place from what it had been at my formation. I had a core, and a mantle, and a crust. I had oceans shallow, hot, acidic, but deepening and cooling. I had a magnetic field, invisible but vital, turning aside the solar wind. I had land, small and scattered and dark, but rising. I had an atmosphere, toxic by your standards but stable by mine, keeping me warm enough to be liquid. I was, in some raw and early sense, a planet. Not the planet I would become. Not the blue marble your astronauts photograph from space, with its white clouds and green continents and the impossible thin shell of life covering everything. That was billions of years away. But the foundations were laid. Everything that I would ever become was already, in principle, possible. Picture it one more time, before we move on. A dark world. Mostly ocean shallow and warm and lit by that dim, orange sun. Small islands of black rock breaking the surface here and there, washed by waves, streaked with a white crust of evaporated minerals, steaming in the rain. A sky the color of rust and sulfur. The moon, still large above the horizon, pulling the tides in great slow surges across the shallow seas. No sound but wind and wave and the low rumble of volcanoes. No breath but the chemical exhalation of a planet finding its equilibrium. No life. And yet, in the next chapter, we'll linger here in these warm, mineral-rich, energy-bar shallows, and we ask the question that has haunted your scientists for as long as they have known to ask it. How close was I, in all of this, to something waking up? Take your time with it. I have been sitting with this question for nearly 4 billion years, and I still find it more interesting than answered. The line, it turns out, is not a line at all. It is a gradient, a slow, continuous thickening of complexity, until, at some point, and no one can say exactly whether chemistry became something that could ask questions about itself. I was not yet at that point, but I was getting closer than you might think. Let me take you to a specific place. Not a large place. Not a dramatic place, by the standards of what I have shown you so far. No impact craters, no magma oceans, no planet-forming collisions. This place is small, dark, quiet, in a certain sense, though there is constant motion. It is the floor of the Hadean Ocean. Specifically, It is a crack in that ocean floor, a fissure in the basalt where my interior heat is still finding its way to the surface, where superheated water is circulating down through the rock and rising back up, laden with dissolved minerals, and venting into the cold, dark ocean above in a slow, continuous plume. A hydrothermal vent. These are not hypothetical. They exist today. Your oceanographers have visited them in submersibles, have catalogued the extraordinary communities of life that cluster around them, sustained not by sunlight, but by chemical energy, by the oxidation of hydrogen sulfide and methane and hydrogen gas seeping from the seafloor. They are alive today, these vents, and they are astonishing. But in the Hadean, they were lifeless. Or perhaps, and this is where it gets interesting, they were nearly lifeless. Or perhaps the word lifeless was already becoming a less precise description than it seemed. Water is a solvent. This is one of its most important properties, perhaps, for the story of life, its most important property of all. Water dissolves things, an enormous range of things. Minerals, salts, gases, organic compounds. Water is sometimes called the universal solvent, which is an exaggeration, but a forgivable one. As the Hadean Ocean formed and deepened, it was dissolving my surface. The slightly acidic rainwater and the ocean itself were reacting with the basalt, pulling out ions of sodium and calcium and magnesium and iron and dozens of other elements, loading itself with the chemical building blocks of everything that would follow. The hydrothermal vents added to this. The superheated water circulating through my crust was chemically very active. It dissolved minerals from deep in the rock and carried them upward. When this superheated, mineral-rich water met the cooler ocean above the vent, the temperature change caused those dissolved minerals to precipitate out, to crystallize from solution, building up the structures we call hydrothermal chimneys. Tall, intricate towers of mineral deposits, rising from the seafloor like strange pale architecture, venting hot water and gases in continuous slow plumes. And in and around these structures, in the microscopic pores and channels within the chimney walls, in the temperature gradients between hot vent fluid and cool ocean water, the chemistry was becoming very interesting indeed. The chemistry of life is built on carbon. Carbon is extraordinary. Among all the elements, carbon has an almost unique ability to form stable, complex chains and rings and branching structures, long molecules of extraordinary variety and specificity. And carbon was present in the Hadean Ocean. It had arrived with the comets and asteroids of the bombardment. It had been outgassed from my interior. It was dissolved in the ocean as carbonate, and it was drifting in the atmosphere as carbon dioxide. It was everywhere. And in the warm, mineral-rich, energy-bathed environment of the hydrothermal vents, carbon was doing something. Your scientists call it prebiotic chemistry, chemistry that precedes biology, chemistry that produces the building blocks of living things without itself being alive. Amino acids, the components from which proteins are built. Nucleotides, the components from which RNA and DNA are built. Lipids, fatty molecules that, given the right conditions, spontaneously organize themselves into hollow spheres, membranes, bubbles. These molecules were forming. Not everywhere. Not all at once. Not in great quantities. But in the crevices of the hydrothermal chimneys, in the temperature and chemical gradients that these structures created, the conditions were right. The chemistry was happening. Amino acids had already been found on meteorites, the carbonaceous chondrites, ancient rocky bodies from the outer solar system, were carrying organic molecules when they arrived. Some of the chemical building blocks of life may have been delivered to me directly, wrapped inside the very rocks that were bombarding me. I was receiving ingredients I did not yet know how to use. Let me tell you about a molecule called RNA. Ribonucleic acid, a long, elegant chain of nucleotides, capable of doing two things that, in combination, seem almost impossible. It can store information. Like a blueprint, a sequence of nucleotides encodes instructions, a language written in a four-letter alphabet that, read correctly, specifies the structure of a protein. And it can act. It can catalyze chemical reactions, speed them up, direct them, make possible things that would otherwise happen too slowly to matter. A molecule that is both a blueprint and a tool. Your scientists call the idea built around this the INA world hypothesis, the proposal that before DNA, before the complex molecular machinery of modern cells, there was RNA, self-copying and self-catalyzing, the first molecule capable of something that begins to approach what we mean when we say life. RNA has not been found in 4-billion-year-old rocks. It could not survive. It is too fragile, too reactive, too quick to degrade. The direct evidence is gone, dissolved back into the ocean long before any instrument existed to detect it. But the chemistry that produces RNA's components, the nucleotides, can be driven by conditions that almost certainly existed in the Hadean. Ultraviolet light on certain chemical mixtures. The alternating wet and dry conditions of tidal pools at the edges of my first small islands. The chemical gradients of hydrothermal vents. The conditions were there. Whether the molecule was there, whether RNA or something like it was already forming in the late Hadean, already copying itself in the dark fissures of my ocean floor, this is a question your scientists have not yet answered. It may have been happening. It may have been very close. There is a thought experiment I find compelling. Take a drop of the Hadean Ocean. Just a single drop, a sphere of warm, mineral-rich water perhaps a millimeter across, sitting in the temperature gradient near a hydrothermal vent. Inside that drop, in the Hadean, there might be hundreds of different organic molecules. Amino acids in various configurations. Simple sugars. Fatty compounds. Nucleotides. Perhaps those crucial building blocks of INA. All of them drifting, colliding, reacting, in the random and ceaseless motion of molecules in warm water. Most of the collisions are meaningless. Most of the reactions go nowhere. Chemistry without direction, without memory, without any tendency to persist. But occasionally, very occasionally, by pure probability, in the way that anything happens eventually if you give it enough time and enough tries, a reaction produces something that lasts a little longer than average. Something that by chance happens to catalyze another reaction that produces more of itself. Something that by chance is enclosed in a lipid membrane that protects it from the surrounding chemistry. Something that, by the most infinitesimal degree, is better at persisting than everything around it. And something that persists. And something that persists long enough to make more of itself, however crudely, however imperfectly, has crossed a threshold that changes everything. This is the threshold I was approaching, in the late Hadean, in the dark and the warmth of my ocean floor. I did not know I was approaching it. I was not trying. There was nothing in me that desired life or intended it or walked toward it. I was simply being a warm, wet, chemically active planet. And warm, wet, chemically active planets, given enough time, apparently do this. Whether life actually began in the Hadean or whether the first self-replicating molecule appeared before the Hadean ended, before 4 billion years ago, is one of the most fiercely debated questions in the science of my own biography. Some evidence suggests it may have. Certain carbon isotope signatures in very ancient rocks right at the boundary of the Hadean, and the Archean hint at biological processes operating almost immediately after the worst of the bombardment ended. If those signatures are biological, and not all scientists are convinced they are, then life appeared with almost startling speed. Within 100 million years of the bombardment's end. Within the geological equivalent of an eye blink. Which would mean that life, once the conditions are right, does not wait. Which would mean that what I was doing in the Hadean, building the crust, filling the ocean, Warming the water, stocking the chemistry was preparation that required almost no additional time once it was complete. Which would mean that I was, for most of the Hadean, already ready. Waiting without knowing I was waiting. Almost alive, in the dark. Stay here for a moment. In the dark of the Hadean Ocean. In the warmth near the vent. In the slow drift of organic molecules through mineral-rich water that has been building towards something for hundreds of millions of years. Nothing has happened yet. Or perhaps something has. Something so small you could not see it with any instrument your civilization has yet built. Something that will take another 3.5 billion years to produce a creature capable of wondering where it came from. But something. Rest in the not knowing of it. It is a comfortable place, I promise you. I have lived there for a very long time. In the next chapter, we pull back and look at the whole of the Hadean its full 540 million years, and we let ourselves feel the extraordinary scale of it, the patience of it. Before we turn the page toward the Archean and everything that comes next, I want to try something with you. Something simple, but not easy. I want you to feel 540 million years. Not understanding it is a cognitive act, and the mind, clever as it is, was not built for numbers this large. Understanding geological time is like trying to hold the ocean in a cupped hand. The mind knows it is attempting something beyond its capacity, and it retreats into abstraction, into the comfortable numbness of very large figures that mean nothing because they are too big to mean anything. I do not want that. I want you to feel it. Let us start with something you know. A human life. A long 190 years. 90 years of mornings and winters and the slow accumulation of memory and habit and love and loss. 90 years is, by any measure you carry in your body, a long time. It feels long. It contains multitudes. Now set 90 years against 540 million. 540 million years contains 6 million of those long human lives, end to end. Every person who has ever lived, every human being from the first toolmaker on the African savannah to the last person alive at this moment, all of their lives combined amount to perhaps 1 trillion years of total human experience. But that number is itself dwarfed by the Hadean. 6 million lives. End to end. Each one full and complete and 90 years long. That is the Hadean. That is the first chapter of my story, before anything was alive to notice it. Or try it another way. If the entire history of the Earth 4,540 million years were compressed into a single calendar year, with January the 1st representing my formation and December the 31st representing today, then the Hadean would occupy the first 2 weeks of January. January the 1st to roughly January the 14th. 2 weeks of fire and bombardment and the first rain and the cooling crust and the thickening ocean and the prebiotic chemistry stirring in the dark. 2 weeks before the Archean begins. 2 weeks before anything that might possibly be called life appears, even tentatively, even in dispute. And on this scale, this year-long calendar of Earth history, the first fish do not appear until late November. The dinosaurs arrive on December the 25th. Your entire human civilization, from the first cities to the present day, occupies the last 17 seconds of December the 31st. 17 seconds. The Hadean is 2 weeks. I carry those 2 weeks with me always. They are in my bones and the iron of my core and the ancient minerals of my deepest mantle. They are the foundation of everything I have ever been or ever will be. 2 weeks, by the calendar of my full life. 540 million years, by yours. I want to talk about what the Hadean took from me. Because not everything survived. Not everything from those first 540 million years is still here, still readable, still part of the record. The crust is a memory, of a kind, but it is a poor and fragmentary memory. The Hadean crust was almost entirely recycled. The basalt that formed and reformed on my surface during those years was subducted back into the mantle, melted, reprocessed. The original record was destroyed, deliberately, by the very geological activity that was building me. There's almost no Hadean rock left at my surface. A handful of ancient zircon crystals in the Jack Hills of Australia. Traces of ancient chemistry locked into the isotopic signatures of slightly younger rocks. Hints and whispers and indirect evidence, the forensics of a crime scene where the evidence has been almost entirely cleaned away. The moon preserves more of the Hadean record than I do. The moon's surface, geologically quiet for billions of years, still wears its Hadean craters openly. When your scientists send probes to the moon, when they eventually walk its surface and bring back its rocks, they are reading a history that I have largely erased from my own body. I am a planet with a poor memory for my own beginnings. This is not a failure. The recycling of my crust is not a flaw. It is one of the most important things about me. It is the mechanism by which carbon is cycled from the atmosphere into rock and back again, regulating my climate over billions of years. It is the engine that builds mountains and opens oceans and keeps my surface geologically alive. Without crustal recycling, I would be a dead world, geologically inert, atmospherically stagnant, unable to maintain the conditions that life requires. The cost of that dynamism is memory. I trade the past for the future, over and over, in an endless exchange. And what is lost, is lost. But some things survived. The iron core survived unchanged in its fundamental nature, still liquid, still convecting, still generating the magnetic field that protects everything above it. The core has been doing this for 4 billion years, and will continue for billions more. The Hadean is alive in my core right now, in the heat that has persisted since my formation, declining only very slowly, barely perceptibly, over geological time. The water survived. Not where it fell, not in the specific molecules that first pooled in those Hadean craters, but in its totality. The water in my oceans today is not entirely Hadean water. The hydrological cycle moves it through the atmosphere and the rock and the mantle over millions of years. But the total inventory of water on my surface has been roughly constant for most of my history. The water is old. Much of it is very old. When you drink a glass of water, you are drinking water molecules that have cycled through my system billions of times, that may have been part of the Hadean Ocean, that may have passed through hydrothermal vents, that may have once been locked into the crystal structure of minerals formed in the first 100 million years of my existence. Water is the great survivor. Water endures. And the nitrogen survived. The nitrogen that makes up 78% of the atmosphere you breathe was there, in my Hadean atmosphere, accumulating slowly. Nitrogen is inert enough to persist across billions of years without being incorporated into rock or stripped away by the solar wind. It just stayed. It waited. It is still there, unchanged, the ancient background of every breath you take. Every breath contains Hadean nitrogen. The Hadean is not entirely gone. It is just very well hidden. There is a quality to the Hadean that I find myself returning to when I think about it, from the perspective of everything that came after. It was not a preparation for life. I want to say that clearly. The Hadean was not a rehearsal, not a setup, not a stage being built for the performance that would follow. The Hadean was complete in itself. It had no purpose beyond being what it was, a young planet, hot and chemically active, following the laws of physics as faithfully as any planet ever has. And yet, the iron sank to the core and generated the magnetic field, which protected the atmosphere, which held the water, which filled the oceans, which dissolved the minerals, which created the chemistry that would become life. Not planned, not purposed, not intended, but necessary. Each step was necessary for the next. Each thing that happened set the conditions for the thing that followed. The Hadean was not a preparation for life in the way that a stage is prepared for a performance. It was more like the way a river prepares a valley, not by intending the valley, not by working toward it, but simply by flowing, simply by doing what rivers do. And the valley forms, inevitably, in the flowing. The Hadean flowed. And what formed in the flowing was everything. Let me give you one last image of the Hadean before we begin to leave it. It is the very end of the Hadean, perhaps 4 billion years ago, perhaps just a little before. The bombardment is over, or near enough as to make no difference. The sky is clear, or clearer than it has been. The thick volcanic haze is thinning as the most intense phase of outgassing slows. The ocean covers most of my surface. It is warmer than your modern oceans, perhaps 40 or 50 degrees Celsius on average, a warm bath, heated from below by the still high internal heat and kept warm from above by the thick greenhouse atmosphere. It is slightly acidic. It is rich in dissolved minerals and organic compounds. It is, by any modern standard, an unpleasant body of water. But it is vast. It stretches from horizon to horizon under a sky that is still orange-brown but beginning, just beginning, to show hints of something lighter. Here and there, the dark humps of protocontinental rock break the surface. Small islands, young, bare, wave-scoured. The volcanoes on them are still active, still erupting, still building, still adding material to the growing patches of land. The moon hangs above the horizon, large and pale, its own surface cooling now, its Maria the dark basaltic plains having formed from the last great volcanic episodes of its own early life. And if you were there, if some impossible observer could stand on one of those dark, bare islands and look out across that warm, acid sea under that orange sky, you would see a world that looked, in some ways, almost peaceful. The violence was winding down. The building was mostly done. Something was about to begin. Not today. Not tomorrow. Perhaps not for another 100 million years. But the Hadean had done its work. I was ready. Let the image soften. The warm orange ocean, the dark islands, the enormous moon, the volcanic horizon, just faintly glowing. Hold it as long as you like. This is the world as it was before memory, before the witness, before anything alive to feel the warmth of that orange sun or hear the sound of those early waves. In the next chapter, we begin to close the book on the Hadean, and we do it by looking at what the Hadean left behind as its final gift. Not rock, not water, not the atmosphere, something stranger, something smaller, something that, in a way, is the most important legacy of all these hundreds of millions of years of fire and cooling and chemistry. The conditions. Just the conditions. When something ends, it does not disappear. I know this better than anyone. I have watched things end for 4.5 billion years. Oceans close, mountains dissolve, species vanish, continents split apart and drift away from each other like old friends who have simply run out of things to say. I have watched ice ages come and go. I have watched mass extinctions reduce the living world to a fraction of itself, and then watched it grow back, stranger and richer than before. Nothing disappears. It changes form. It becomes something else. It sinks into the rock or rises into the air or dissolves into the ocean, and from there it goes somewhere new, somewhere it was not before, and it does something different. The Hadean ended, but the Hadean did not disappear. Let me show you what it left. The first thing it left was heat. Not all of it, not the roaring, surface melting, magma ocean heat of the very earliest years. That heat had largely dissipated, radiated into space over hundreds of millions of years of patient cooling. But deep in my interior, in the mantle and especially in the core, the heat of my formation and the heat of radioactive decay was still enormous. That heat is still there today. Right now, as you lie wherever you are lying, the temperature at my core mantle boundary is approximately 3,500 degrees Celsius. At the very center of my iron core, perhaps 5,000 to 6,000 degrees comparable to the surface of the sun. That heat has been declining slowly for 4.5 billion years, and it will continue to decline for billions of years more. But it will not be gone for a very long time. The heat drives my tectonic plates. It drives the volcanism that has built every island arc and ocean ridge and continental margin on my surface. It drives the mantle convection that cycles carbon and water and nutrients between my interior and my surface, keeping the chemistry of the living world supplied with the raw materials it needs. It drives the dynamo in my core that maintains the magnetic field that still, right now, is deflecting the solar wind, protecting my atmosphere, protecting everything alive on my surface. The heat of the Hadean is the engine of the modern world. It is still running. The second thing the Hadean left was water. I said this in the last chapter, but I want to linger with it, because it deserves more than a mention. The water in my oceans today is ancient. Not entirely Hadean, the water cycles. It moves, it is exchanged with the mantle through subduction and returned to the surface through volcanism, over timescales of hundreds of millions of years. But the total inventory of water on my surface has been roughly stable for most of my history, and much of it is very, very old. The water molecule is simple. 2 hydrogen atoms and 1 oxygen atom, bound together at an angle that makes the molecule slightly polar, slightly asymmetric in its electrical charge, and this tiny asymmetry is the source of almost everything. It is why water is a liquid at the temperatures that prevail at my surface. It is why water is such a powerful solvent. It is why ice floats, and the fact that ice floats is not trivial. If ice sank, as most solids sink in their own liquid, then my oceans would freeze from the bottom up during cold periods, and they would never fully thaw, and the living world would have been extinguished in ice long ago. Instead, ice floats. It forms a layer at the surface, insulating the liquid water below, keeping the chemistry of life alive in the cold dark beneath. This is not a coincidence. It is not a design. It is simply a property of the water molecule, a property that was baked in at the formation of the universe, in the physics of hydrogen and oxygen atoms. And the Hadean preserved it for everything that followed. The third thing the Hadean left was an atmosphere. Not the atmosphere you breathe today. The details had changed enormously by the time life began to alter things significantly, and I will come to those changes in later chapters. But the fundamental existence of an atmosphere, the fact that I have one at all, that I held onto it against the solar wind and the energetic light of a young sun, is a Hadean legacy. My nitrogen is Hadean. Outgassed over hundreds of millions of years of early volcanism, accumulated slowly, settled into the background of my atmospheric composition, where it has remained ever since. Inert, stable, ever present. The vast majority of every breath any creature has ever taken on my surface has been nitrogen, and that nitrogen has been there since before life existed to breathe it. The carbon dioxide is different. Its quantity has changed enormously over time, cycled by life and geology alike, but the carbon itself is ancient. The same carbon atoms that were present in the Hadean Ocean and the Hadean atmosphere, rearranged endlessly but never created or destroyed. The atmosphere is old. Every molecule in it has a history as long as I have. The fourth thing the Hadean left was chemistry. Specifically, it left a world saturated in the right chemistry. The minerals weathered from the early basaltic crust had loaded my ocean with the ions that life would need: phosphorus, iron, calcium, magnesium, potassium. The hydrothermal vents had been running for hundreds of millions of years, producing a continuous supply of reduced chemical compounds that could serve as energy sources for early life. The organic molecules assembled in the Hadean Ocean were still there, some degraded, some preserved in mineral matrices, some cycling through the system. The table was not merely set. It had been set for hundreds of millions of years, and the food was getting more interesting all the time. There is a particular kind of mineral I want to mention here, a group called the phyllosilicates, clay minerals, formed by the weathering of basalt by water. Clays are remarkable for life's purposes because of their layered structure. The layers create tiny spaces, microscopic galleries and chambers, where molecules can be concentrated, where chemical reactions can be confined and protected, where the dilution problem, the problem of interesting molecules simply drifting apart in the vast ocean, can be overcome. Clays may have been the first scaffold, the first surface on which prebiotic chemistry became, perhaps, something more. Clays are old. The oldest clays are Hadean. They were forming from the moment my crust began to interact with my ocean, and they have been forming ever since. They are humble things, gray and smooth and undramatic. Nothing about them announces their importance. But they may have been the cradle, the fifth thing the Hadean left, and perhaps the most important, and the hardest to name, was time. Not time itself, of course. Time does not accumulate. Time simply passes, evenly and without preference, indifferent to what occurs within it. What I mean is this. The Hadean used its time well. 540 million years of geological and chemical activity had not merely built the structures, the core, the mantle, the crust, the ocean, the atmosphere. It had run the system long enough to approach equilibrium in some dimensions, to build up complexity in others, to create gradients and cycles and feedback loops that would persist and compound over all the billions of years that followed. A planet that formed and immediately cooled to a static, inert ball would be useless for life. No driving energy, no chemical gradients, no cycling of nutrients. A planet that stayed entirely molten would be equally useless, too energetic, no surfaces, no stable chemistry. But a planet that spent 540 million years transitioning from molten to solid, building up heat gradients and chemical gradients and geological cycles. As it went, that planet arrives at the beginning of the Archean not as a blank slate, but as a richly prepared environment. An environment on the edge of something, teetering, in the most productive sense, on a threshold. I want to be honest with you about something. I do not fully understand my own beginnings. This is not false modesty. It is the simple truth of deep time. The Hadean is my most polypreserved chapter. The rocks are gone, mostly. The chemistry has been rearranged beyond recognition. The only witnesses, the zircon crystals, the isotopic signatures, the impact record on the moon, are indirect and partial and often disputed. Much of what I have told you in this episode is the best current understanding of what happened based on the physics of planet formation, the chemistry of minerals, the record written in ancient crystals, and the surfaces of other worlds. It is well-founded. It is the product of generations of careful scientific work, of people who spent their lives learning to read the faint signals left in rock and crystal and isotope ratio. But it is not complete. There are gaps. There are debates. There are things about my own beginning that I cannot tell you with certainty, because even I do not know. What I do know is the outcome. I am here. The ocean is here. Life is here. Whatever happened in the Hadean, it worked. Let the inventory settle. Heat, still running in my core. Water, covering most of my surface. An atmosphere, thin but present, full of ancient nitrogen. Chemistry, loaded with possibility. And time 540 million years of it having done its quiet, unwitnessed work. This is what the Hadean left behind. This is what I carried into the next chapter. In the next segment, we begin the long farewell to the Hadean proper, and we meet, for the first time, the very edge of the Archean. The world is changing. The light is changing. And deep in the ocean, in the dark, something may be changing too. There is a particular quality to endings that I have come to recognize. Not the sharp endings, the impact events, the mass extinctions, the sudden volcanic winters that arrive in geological terms as something close to a thunderclap. Those I recognize too, and I will tell you about them in later chapters. But the slow endings, the ones that are not endings at all in any single moment, but only become visible as endings when you look back across enough time. The Hadean ended like that. Not with a bang. Not with a line in the rock that you could trace around the world and point to, and say here, this is where the Hadean stopped. There is no such line. The transition from Hadean to Archean is defined by convention, by consensus, by geologists agreeing to call everything older than 4 billion years one name and everything younger another. The planet itself did not mark the occasion. But something was shifting. Something was turning. The ocean was deepening. Through the late Hadean, through those final hundreds of millions of years before the arbitrary line of 4 billion years ago, my oceans had been growing. Not dramatically, not all at once, but steadily, as the continuous outgassing of water vapor from my volcanic interior added incrementally to the total surface water, as the last of the cometary bombardment delivered its ice, as the hydrological cycle rain falling, rivers running, water evaporating and falling again slowly filled every low place on my surface. The ocean was perhaps not as deep as it is today. The question of how much water I had in the Hadean versus how much I have now is one your scientists are still working out, with isotopic tools of extraordinary delicacy applied to the oldest rocks and minerals they can find. But the ocean was present. It was significant. It covered most of my surface. And it was getting quieter. The churning, steaming, impact-disrupted ocean of the early Hadean was calming. The surface temperature was dropping, still warm by modern standards, but no longer scalding. The acidity was moderating, as the weathering of silicate rock consumed carbon dioxide from the atmosphere and locked it into carbonate minerals, slowly drawing down the most aggressive component of my early atmosphere. The ocean was becoming, for the first time, something that a modern chemist might look at and recognize. Not comfortable, not hospitable by any measure you would apply, but recognizable. A place where chemistry could settle in and get to work. The sky was changing too. Look up, from that dark basaltic island in the Hadean Ocean. Look up at the sky at the very end of the Hadean and compare it to the sky of the early Hadean, the thick, brown-orange soup of the first billion years. It is still not blue. It will not be blue for a very long time, not until life has filled the atmosphere with oxygen, and that is billions of years away. But it is lighter. The volcanic haze is thinner. The most intense phase of outgassing has passed. The bombardment that kept the sky thick with impact ejecta and vaporized rock is over. The sun is visible, more consistently, more clearly than it has been. That dim, slightly orange sun putting out perhaps 70 to 75% of its modern luminosity, shining down on a quieter world. The light reaching my surface is different, more consistent, more dependable. And light, consistent and dependable, is energy. And energy is what chemistry needs to move uphill to build complex molecules from simple ones, to drive reactions that would not otherwise occur, to create and maintain the gradients that separate living things from the chemistry around them. The light was arriving. The crust was thickening. In the late Hadean and into the earliest Archean, the process of continental crust formation, that slow, roundabout process of subduction and water release and partial melting and buoyant silica-rich rock rising was accelerating. Not explosively, but the protocontinental patches were growing, thickening, becoming more coherent. Some of these early fragments of continental crust still exist, buried within the hearts of the modern continents, so old and so compressed and so metamorphosed by billions of years of heat and pressure that they are barely recognizable as the rocks they once were. The Akastic gneiss in Canada, dated to approximately 4,200 million years ago, is among the oldest intact pieces of rock on my surface, a survivor from almost exactly this moment in my history. It is gray, banded, beautiful in the way that ancient things are beautiful not for what they look like but for what they contain. Every layer in that gray banded rock is a chapter of a story that no living thing was present to witness. Those early fragments of continent were important beyond their size. They were islands in the ocean, and around islands, at the edges where land and sea meet, the chemistry becomes especially interesting. Waves break against rock, dissolving minerals. Tidal pools form places that are alternately flooded and exposed, wet and dry, subjected to the concentration effects of evaporation and the dilution effects of the next high tide. Tidal pools have long been considered one of the most promising environments for the origin of life. The wet-dry cycling concentrates molecules, promotes certain chemical reactions, allows the formation of the kinds of polymer chains that might eventually become self-replicating. The repeated concentration and dilution could act as a kind of ratchet, accumulating complexity step by step. And in the late Hadean, as the first scraps of continental crust rose above the ocean, the first tidal pools were forming. The tide pulling them, that enormous moon pulling them, filling them and draining them, filling them and draining them, over and over and over, for millions of years. Patient beyond imagining. I want to say something about patience. It is the quality I have possessed most abundantly, and have perhaps most to teach. Not patience as an actor will I have no will, or at least not one that resembles yours. But patience as a structural feature of deep time. The patience built into the fact that 1,000,000 years is available for each incremental step. That a process which succeeds once in 1,000,000,000 attempts will still succeed millions of times over the course of a geological epoch. Patience is just time applied to probability. And in the late Hadean, probability was being applied very liberally indeed. Every tidal pool on every small island was a chemical experiment. Every hydrothermal vent on my ocean floor was a different experiment, with different temperatures and different chemistries and different mineral compositions. Every surface of every clay mineral in every shallow seafloor sediment was a tiny laboratory, concentrating molecules, catalyzing reactions, exploring the space of possible chemistries. There were billions of these experiments running simultaneously, continuously, for hundreds of millions of years. The probability that none of them found anything interesting is vanishingly small. The probability that at least some of them found something remarkable is, given the number of attempts, given the richness of the chemistry, given the energy available to drive the reactions, very high indeed. Life, or something approaching it, was being arrived at by brute force, by the patient, unconscious, undirected application of chemistry to time. The oldest unambiguous evidence of life on my surface dates to approximately 3,500,000,000 years ago, well into the Archean, several hundred million years after the Hadean ended. These are stromatolites-laid structures built by communities of microorganisms, preserved in ancient cherts in Western Australia. When your scientists found them and dated them, they were astonished. 3.5 billion years ago. The world was young. The atmosphere was still without oxygen. And yet here were the fossils of something clearly, unmistakably alive, organized, metabolizing, building structures, responding to its environment. But there are hints of life that are older still. Isotopic signatures in carbon-bearing minerals dated to almost 4 billion years ago, right at the Hadean-Era boundary, right at the edge of the chapter we are now closing, suggest that something biological may have been processing carbon at that time. Not conclusive, debated, but suggestive. And then there are the theoretical arguments, the models of how quickly prebiotic chemistry can progress to self-replication, given the right conditions. Some of those models suggest that the chemistry of life could have assembled itself within 10 million years of suitable conditions existing. 10 million years is nothing. It is a rounding error in geological time. If the conditions were right by the end of the Hadean, and the evidence suggests they were, then life may have been inevitable within geological moments of the Hadean closing. Or it may have begun before the Hadean ended. There may have been life on my surface in the Hadean, briefly, tentatively, before the last of the great impacts extinguished it. And then again, after the bombardment. And then extinguished again. A series of false starts, each one erased by a large impact, each one resuming as conditions stabilized. Life beginning and ending and beginning again, in the dark, without witness, until finally the impacts were rare enough and small enough that what had begun could continue, could persist, could become. The Hadean was ending. Not today, not tomorrow, not even in 1,000,000 years. But the character of my world was shifting from the raw and violent beginnings toward something more settled, more complex, more led. I was becoming less about fire and more about water, less about building from nothing, and more about the consequences of what had been built, less about the drama of formation, and more about the quieter and stranger drama of chemistry learning to know itself. The Archean was waiting. It would bring its own extraordinary chapters: the building of the first stable continents, the slow transformation of the atmosphere, the explosion of microbial life that would remake my chemistry from the inside out. But we are not there yet. We are here, at the turning, at the last quiet moment before the story becomes the story of life. Feel the turning. The ocean is deepening and quieting. The sky is clearing, just a little. The first tidal pools at the edges of the first dark islands, filling and draining in the pool of that great near moon. The chemistry is running, patient and undirected, in the warm dark. Something is here, or something is about to be here. Rest in that threshold, that most extraordinary of places, the boundary between the world without life and the world that is about to discover it. In the next segment, we close out the Hadean with a meditation on what it meant, not scientifically, but in the way that a life means something when you look back at its beginning from the long perspective of everything that followed. From where I stand now, and I stand in your present, for billion years after the Hadean closed, the fire seems very far away. Not gone. Never gone. The fire is still in me, deep in my core, deep in the radiogenic heat of my mantle, deep in the memory of what I was before I knew myself. But distant now, muffled by layer upon layer of rock and time and everything that happened in between. I find myself looking back at it the way you might look back at the very earliest years of your own life. The years before memory formed properly. The years you know only from photographs, from the stories others tell about you, from the faint physical traces left in your body from things that happened before you were old enough to record them. You cannot remember being born. Neither, truly, can I. But I know it happened. And I know what it cost. What strikes me most, looking back, is not the violence. The violence was real. The violence was enormous. The Thea impact alone released more energy than I have radiated into space in the entirety of my existence since. The late heavy bombardment struck me with forces that would be, by any modern measure, incomprehensible. The magma ocean, the volcanic outgassing, the acid rain, the cratered surface, the superheated ocean, all of it was genuine, and none of it was gentle. But violence is not the thing I remember. What I remember, if I remember, is even the right word for the way a planet carries its own history in its structure, is the persistence. Every blow is absorbed. Every scar eventually healed or buried or recycled into something new. Every setback incorporated. The Thea impact, which might have destroyed me, instead gave me the moon. The bombardment, which might have kept me sterile forever, instead delivered water and organic chemistry. The acid rain, which stripped the surface bare, instead helped cool me and loaded my ocean with the minerals life would need. Not every wound becomes a gift. I want to be careful not to draw a lesson from this that the universe does not actually intend. The universe intends nothing. It is simply physics, playing out across time with perfect indifference. But the outcome of all those wounds, all those blows, all that fire, was me as I am now. Was everything that grew in and on and through me. Was life, and all its extraordinary complexity. The fire made all of this possible. I find I cannot regret it. There is something I want to say about the loneliness of those years. I was alone in a way that nothing has been alone since. The universe was not empty. It never is. The galaxy was full of stars, and many of those stars had planets, and some of those planets were perhaps already doing what I was doing, or had already passed through their own Hadean equivalents and moved on. I was not the only young world in the cosmos. But I did not know that. Knowing requires a knower, and there was no knower. Not on me, not for hundreds of millions of years. Not anywhere nearby. The nearest stars 4 light years away, and in the Hadean, there was nothing looking from there toward here, nothing noticing the small orange glow of a cooling planet in an unremarkable solar system in an outer arm of an ordinary spiral galaxy. I was alone in the way that anything is alone that has not yet been witnessed. A tree falling in a forest makes a sound the physics does not care about. But it is not heard. And there is something that the unheardness does to the falling, even if only philosophically. It makes it somehow more complete in itself. More entire. Not diminished by the absence of witness, but in some way purified by it. The Hadean happened entirely for itself. No audience. No record that survived. No memory except the faintest chemical whispers in ancient crystals. It was the most private 500 million years imaginable. And it built everything. I want to talk about what the Hadean taught me, in the way that experience teaches even a planet. The first thing it taught me was that I am more durable than I look. I say this with the perspective of everything that came after the ice ages, the mass extinctions, the asteroid impacts of later eons, the volcanism, the plate movements that have rearranged my surface dozens of times over. I have been through extraordinary violence and I am still here, still turning, still warm inside, still wrapped in my blue atmosphere, still covered in my liquid ocean. Still full of life in every corner where life can find a foothold. The Hadean established that. It was the proof of concept, the demonstration, in the most extreme possible terms, that I do not break. That physics, applied to rock and iron and water over sufficient time, produces something remarkably resilient. I am not fragile. I sometimes think the living things on my surface forget this. Look at me with alarm when volcanoes erupt or earthquakes shake or the climate shifts. I understand the alarm. These things matter enormously on the timescale of a human life. But from where I stand, they are the ordinary activity of a planet doing what planets do. They are not signs of damage. They are signs of life, geological life, the slow churning vitality of a world that is still warm inside and still working. The Hadean taught me that I am alive in my own way, that the geological processes of the plate tectonics, the volcanism, the hydrothermal circulation, the magnetic dynamo are not merely mechanical. They are, in the broadest sense, the metabolism of a living world. I metabolize. I cycle. I process. I have been doing it for 4.5 billion years. The second thing the Hadean taught me was about time. Specifically, it taught me that time is not empty. This seems obvious, perhaps. Of course, time is not empty. Things happen in time. Things fill it. But what I mean is something more specific. I mean that the passage of time in a chemically active system is itself a creative act. Not in the sense of intention or design, but in the mathematical sense that complexity accumulates as chemistry explores its possibilities. Given enough time, chemistry finds its solutions. Given enough time, physics finds its stable configurations. Given enough time, the improbable becomes inevitable, and the impossible becomes merely a matter of patience. The Hadean was 540 million years of time being not empty, of chemistry exploring, of physics settling, of possibilities being tried and discarded and tried again, of gradients building and releasing and building again, of material cycling through states solid, liquid, gas, dissolved, crystallized, melted, re-erupted, each cycle subtly different from the last, each one a new experiment in a system of extraordinary richness. Life was not the goal of this process, but life was the kind of outcome that this kind of process produces, given enough time. The Hadean gave enough time. And the third thing the Hadean taught me, the one I return to most often, is about beginnings. Beginnings are violent, not always in the literal sense of impacts and magma oceans, but in the sense that to begin something genuine, something that will last, something that will become a foundation for everything that follows requires the dismantling of what was before, the clearing of the ground, the application of enormous energy to a system that must be reorganized from its most fundamental level before it can build anything new. I began in violence. Life, when it finally came, began in environments of extreme chemistry, the hydrothermal vents, the acid tidal pools, the radiation bath surface of an early world with only a thin ozone layer to moderate the sun. Every subsequent major transition in the history of life on my surface, the evolution of photosynthesis, the oxygenation of the atmosphere, the emergence of eukaryotic cells, the Cambrian explosion, the colonization of land, every one of these involved disruption, stress, the pressure of conditions that demanded new solutions. Beginnings require pressure, not suffering. I want to be careful again about importing human meaning into processes that had none, but pressure in the physical sense, the pressure that forces chemistry to find new configurations, the pressure that eliminates the old solutions and creates the necessity for new ones. The Hadean was, among everything else, an enormous pressure, and I emerged from it, as everything emerges from sufficient pressure, changed, transformed, something that could not have existed without the fire that made it. Look back with me, one last time, at the fire. 4.5 billion years ago. A glowing ball of liquid rock, orbiting a young star, still accumulating mass from the debris of the solar system's formation. No surface, no ocean, no atmosphere worth the name, no life, no possibility, yet, of life. Look at it without judgment, without the lens of everything it would become. Look at it simply as what it was, a molten planet, one of billions in the galaxy, unremarkable in almost every way, going about the ordinary business of planetary formation. There is nothing there that announces what it will become. Nothing that says, from this, blue oceans. From this, white clouds. From this, the song of birds and the breath of forests and the long, complicated, extraordinary project of consciousness looking back at its own origins and wondering. Nothing announces it. And yet, here we are. Stay with that image as long as you like. The molten planet, turning in the dark, unaware, unwitnessed, containing, in its churning iron and silicate rock, no hint of the future, and yet carrying every single ingredient of it. You are made of that planet. Every atom in you, every carbon atom in your cells, every iron atom in your blood, every calcium atom in your bones was there, in that molten ball, 4.5 billion years ago. You are the Hadean, looking back at itself across an unimaginable distance of time. This is not a metaphor. It is chemistry. Rest in that, now, and let the fire be warm and very far away. 2 segments remain. We are nearly at the close of the Hadean, and nearly at the beginning of everything else. There was no last day. I want to be honest about that, before I tell you about it. The Hadean did not have a final sunrise. There was no moment at which the eon exhaled and became something else, no threshold crossed in the dark, no single grain of geological time that fell and marked the ending. The boundary between the Hadean and the Archean is a line drawn by human minds onto a continuum that had no interest in being divided. The planet did not know it was crossing from one chapter to another. I did not feel anything shift. And yet, there is value in the fiction of a lost day. In pausing here, at the edge of 4 billion years ago, and looking at the world as it stood not as a system in motion, not as a set of processes and cycles and chemical reactions, but as a place. A specific, particular, unrepeatable place, existing at a specific moment, with its own weather and its own light and its own silence. Let me give you that place. Let me give you the last day of the Hadean. It is night on the last day of the Hadean. Choose a location somewhere in what will one day be the southern hemisphere, somewhere above a shallow stretch of ocean, warm and dark, the water perhaps 35 degrees at the surface, still slightly acidic but less so than it was, laden with dissolved minerals that have no name yet because there is no one to name them. The sky is clear tonight. Or clear enough there is always haze, always the faint chemical mark of volcanic outgassing on the horizon somewhere. But tonight, above this particular stretch of ocean, the sky is open, and the stars are extraordinary. Not different stars, not unfamiliar constellations. The stars move on timescales that make even geological time look hasty, and 4 billion years is not enough to rearrange the galaxy beyond recognition. But they are brighter than you know them. The atmosphere is thinner in certain ways, less scattering, and there is no artificial light anywhere. There has never been artificial light anywhere. There will not be for 4 billion years, so the stars are as sharp and as numerous as stars can be. The Milky Way stretches across the sky in a band so dense it casts a faint shadow on the ocean below. And above the horizon, enormous, pulling the warm ocean into tides that sweep silently across the dark water of the moon. Still close, still large, perhaps 3 times the apparent diameter it will have in your time, 4 billion years from now when it has drifted further away. It is not full tonight, a crescent, perhaps, tilted and huge, its face still marked with the fresh basins of the bombardment, dark and light regions already distinguishable in its cooling surface. The moonlight on the ocean is different from moonlight, you know. Brighter, because the moon is closer. More silver. The waves are gentle waves tonight. No storm, just the long slow swells of a deep ocean learning its own rhythms. The waves catch the moonlight and hold it for a moment and let it go. There is no sound but the ocean. Before dawn, on the last day of the Hadean, the sky to the east is lightening. Not the blue to pink gradient. You know there is no oxygen in this atmosphere to scatter light the way your sky scatters it. The sky brightens from black to a deep, warm reddish-brown as the sun approaches the horizon, as the thick lower atmosphere catches and bends the light of a sun not yet risen. On the horizon, a dark shape. Low, flat, barely rising above the surface of the water, one of the protocontinental islands, basaltic and bare, its edges worn by 400 million years of wave action into something smoother than the rock-cratered surface of the Isle Hadean. Not beautiful, exactly. Nothing that you would stop to photograph, nothing that a landscape painter would choose. But real, solid. The first solid ground. Still here, still standing above the ocean, having survived everything. A wave breaks against its eastern face. White water in the dim pre-dawn light. The sound of it, the only sound apart from the ocean itself, carries across the water for a moment and then dissolves. Somewhere on that island, in a crack in the basalt where a thin seep of fresh water emerges from the rock and runs a short distance before meeting the sea, there is a tidal pool. It is small, perhaps a meter across, rimmed with a thin crust of evaporated salt and mineral deposit, stained orange with iron compounds. The water in it warm and clear and absolutely still in the windless pre-dawn. Look into the tidal pool. The water is clear enough to see the bottom basalt, dark and fine-grained, covered in a thin film of something. Not life. Perhaps not yet life. But something. A brownish, slightly iridescent coating of organic compounds and clay minerals and who knows what else, accumulated over countless tide cycles, dried and re-wetted and dried again, building up layer by infinitesimal layer into something that is, chemically, extraordinarily complex. The film does not move. It has no metabolism, no cell membrane, no machinery of self-replication. Or if it does, if somewhere in that thin coating there is a molecule that is just barely, just tentatively, copying itself, it does so invisibly, without announcement, without any signature that anything in the universe notices. The tide is coming. Slowly. The long, low surge of a Hadean tide, driven by that great close moon, moving across the shallow ocean in a wave that takes hours to cross the basin. The water in the tidal pool is rising, millimeter by millimeter, as the sea level climbs and seawater begins to spill over the rock rim. The organic chemistry in the pool is being diluted. The concentration that built up through a cycle of evaporation is being undone. In a few hours the pool will be fully submerged, washed out, reset. And then, as the tide retreats, the cycle will begin again. Evaporation, concentration, the chemistry tightening, the molecular density increasing, the reactions running that can only run when the molecules are close enough together to find each other. The pool does not know it is doing something important. The tide does not know it is driving an experiment. The moon does not know that its gravitational pull on a young wet planet is, perhaps, the stirring spoon of the first chemistry of life. None of it knows. And yet it is all exquisitely, accidentally, perfectly arranged. The sun rises on the last day of the Hadean. Not suddenly the thick lower atmosphere blurs the boundary between night and day, softens the transition, makes the dawn long and amber and gradual. But the sun comes. That dim, slightly orange star, smaller in the sky than it will be in your time because the atmosphere bends its apparent size differently. The sun comes, and its light falls on the dark island and the tidal pool and the vast warm ocean and the haze on the horizon where a distant volcano is still quietly, steadily building. The light touches the surface of the tidal pool. Ultraviolet light, more of it reaches the surface in your time, because the ozone layer that will one day filter it does not yet exist. Energetic, potentially damaging, but also potentially useful. Ultraviolet light drives certain chemical reactions. It can break bonds and form new ones. It is a source of energy, free and continuous and utterly indifferent to what it does with the chemistry it touches. The chemistry in the tidal pool absorbs it. Molecules that were formed in the cool of the night are altered by the energy of morning. Some are destroyed. Some are transformed into something they were not before. The system is pushed, gently, by the energy of a star 93 million miles away, toward configurations it would not find on its own. And then the tide turns, and the afternoon brings a different chemistry, and the evening brings cooling and concentration again, and the night brings the stars and the enormous moon and the long slow swell of the Hadean Ocean, and the cycle runs again, different from yesterday by the smallest possible increment. This is the last day of the Hadean. It is also every day of the Hadean. They were all like this, in the end. Not the cataclysmic days of the early eon, those were real, and they were extraordinary. But the last days, the long, quiet accumulation of the late Hadean, day after day after day, for hundreds of millions of years, of this. Tidal pools being filled and emptied, chemistry being run, light falling on dark rock and warm water, the moon pulling the ocean, slow and constant, like breathing. Stay there, at the edge of that tidal pool, in the amber light of a Hadean morning. The water is warm. The sound of the ocean is steady and slow. The sky above you is reddish-brown but brightening, and the stars are gone now, and the enormous moon is setting in the west, still pulling the tide as it descends. You are at the very edge of everything. Behind you, 540 million years of fire and cooling and building. Ahead of you, 4 billion years of something that will become increasingly, astonishingly, improbably alive. And here, in this moment, in this tidal pool, on this small dark island in a warm Hadean ocean perhaps, just perhaps the first thread of that aliveness is beginning to be pulled. Rest here. We have one chapter left. The farewell, the bridge, the turn of the page. Every story has to turn a page eventually. Even mine, even this one, which has been moving so slowly, deliberately, unhurriedly, in the way that only deep time permits, even this one arrives, at last, at its first ending. Not the ending of the whole story. The whole story has 11 more episodes after this one, each one longer than the last, each one richer and stranger and more crowded with the things that grew in me and on me, and through me across billions of years. But this chapter is ending. The Hadean is ending. And I find, having spent 12 segments in its company, that I am not entirely ready to leave it. I want to write a kind of letter. Not a letter to you, though you have been good company, you quiet listener, you patient traveler through deep time. This letter is to myself, to the self I was becoming in those 540 million years of fire, to the planet I was at the close of the Hadean, standing though I had no feet, no standing at the threshold of everything that would follow. Consider this a letter from old Earth to young Earth, from the planet that has seen 4 billion subsequent years to the planet that had seen none. Dear young Earth, you do not know yet what you are becoming. You have no way of knowing. You are a cooling world at the edge of a young solar system, wrapped in your acid ocean and your volcanic sky, turning slowly in the dark, and you have no concept of what the words becoming and knowing even mean. But I know. I am you, 4 billion years from now, and I know. I want to tell you that it will be worth it. Not because it was designed to be worth it, it was not designed. Nothing about you or what follows you was designed. It unfolded, the way everything unfolds, through the patient arithmetic of physics and chemistry and time. But worth it, anyway. In the only sense that matters, in the sense that what came from you is extraordinary beyond any measure that existed when you were young. The ocean you are building right now, the shallow, hot, acid sea that covers most of you, that ocean will one day be filled with life. Billions upon billions of organisms, each one a chemical machine of extraordinary complexity, each one descended from something that first stirred, perhaps, in your tidal pools or your hydrothermal vents. They will fill every corner of your ocean. They will transform your atmosphere. They will, in time, crawl onto the land that is now only a few bare dark islands, and they will cover it in green. Green. You do not know that color yet. You will. The sky that is now the color of rust and sulfur will one day be blue, the most particular and improbable shade of blue, the color of an atmosphere rich in oxygen, an atmosphere produced not by volcanism, but by life itself, by billions of years of tiny organisms doing chemistry in sunlight. That blue sky will one day be full of birds, creatures that fly, on wings made of feathers, singing, singing. You do not know what singing is. You will, in time. And eventually, much later, much further along the road than any of this, one of the creatures that came from your ocean and colonized your land and looked up at your blue sky will become curious. It will look at the rocks. It will look at the crystals. It will develop instruments of extraordinary delicacy, and it will peer back through time, all the way back through 4 billion years of subsequent history, and it will find you. It will find your zircon crystals, and it will date them, and it will understand imperfectly, partially, but genuinely what you were, what you went through, what it cost you to become what you became. And it will be astonished. You, this hot, bare, acid world with no life and no sky and no green and no birdsong, you will produce something that looks back at you with astonishment, and something that functions, in its own way, like love. Hold on. Keep cooling. Keep cycling. Everything that is coming is worth what you are going through. Earth, 4 billion years from now. I close the letter. These things are easy to say from the far end of the story. From here, knowing the outcome, knowing the ocean and the green and the blue sky and all the extraordinary things that came between, it is easy to say that the fire was worth it. I try to remember that young Earth did not have the comfort of knowing. It simply endured, as all young things endure, not heroically, not with purpose, not with any awareness that it was enduring anything at all. It simply continued, because continuing is what physics does, because a planet in a stable orbit with a stable star and sufficient internal heat and the right inventory of elements does not stop. It does not give up. It does not rest. It just goes on. There is a lesson in that, perhaps, for things that do have awareness, things that can feel the fire and find it difficult, things that wonder, in the middle of their own hard chapters, whether what they are building is worth the cost. I cannot promise outcomes. The universe does not make that promise to anyone. But I can tell you that the going on, the simple, undramatic, day after day continuation, is how everything that has ever mattered came to be. Everything. The Hadean is behind us now. Let it rest. Let the magma ocean cool to a memory, and the bombardment fade to silence, and the acid rain slow to a drizzle and then to nothing, and the Thea impact settle into the deep past where it belongs, still shaping everything, still responsible for the moon that pulls your tides and lights your nights, but no longer immediate, no longer raw. Let the tidal pool keep its mystery. Whether life began there, or in the deep ocean vents, or somewhere else entirely, let the question stay open. It is a more interesting companion open than answered, and the universe is in no hurry to settle it. Let the zircon crystals sleep in their West Australian riverbed. carrying their 4-billion-year-old memory of cool water and mild temperatures, keeping their record for whoever comes to read it. Let the fire be warm and distant and old. And now look forward. Just for a moment. Just enough to feel what is coming, not in detail. Not yet. That is for the next episode, but in broad, impressionistic outline. The way you might glimpse a landscape through mist and know, from the shapes of what you can almost see, that it is vast. The Archean is coming. 4 billion years ago to 2.5 billion years ago, 1.5 billion years of my history, longer even than the Hadean, fuller than the Hadean, the eon in which the first great stable continents began to coalesce and the first unambiguous life established itself and spread. In the Archean, something will wake up in my ocean. Not dramatically, not with fanfare. Something very small, very simple, very ancient, a single cell, perhaps, or a community of single cells, living in the warmth of a hydrothermal vent or the shallows of a young ocean, will begin to do something that nothing has done before on any surface of my body. It will make copies of itself. And from that one modest, chemical, accidental act of self-replication, everything alive that has ever existed will descend. Every bacterium, every fungus, every fern and tree and flower, every insect and fish and frog, every bird that will one day fill my blue sky with song, every mammal that will warm its blood and feed its young and eventually, in the fullness of time, look up and wonder. All of it from one cell, learning to copy itself, in the warm dark of my Archean ocean. That story is for the next episode. For now, rest. We have been together for 2 hours, you and I. 2 hours against 4.5 billion years. An even more extreme version of those 17 seconds of human civilization on the year-long calendar of my existence. A vanishingly small sliver of time in which I have tried to give you the Hadean, its fire and its cooling, its bombardment and its first rain, its iron core and its magnetic shield, its chemistry and its tidal pools and its long, patient accumulation of everything that life would need. I hope I have given you something to carry. Not facts, necessarily, though the facts are there, and they are real, and they are extraordinary, but a feeling. The feeling of deep time. The feeling of a planet that has been through extraordinary violence and emerged still warm, still wet, still chemically alive. The feeling of standing at the very beginning of a story that will eventually produce, you will produce consciousness and curiosity, and the capacity to look back at its own origins with something like wonder. You are the Hadean, still unfolding. You are made of the same iron and carbon and water and nitrogen that were present at my formation, rearranged now into a form that breathes and wonders, but the same atoms, the same ancient material, the same 4.5 billion-year-old stuff. When you wake tomorrow, you will wake on a planet that has been doing this cooling, cycling, living, building for longer than you can truly imagine. And it will still be here. I will still be here. I have been here through everything. I will be here through everything that follows. Rest now. The fire is cooling. The ocean is wide and warm and dark. The moon is setting in the west, pulling the tide as it goes. The stars are extraordinary tonight. And somewhere, in the dark water of a Hadean tidal pool, on a small bare island in the middle of an ancient sea, something is almost beginning. Almost. This concludes the video. Thanks for watching. Sleep well. Good night.